All right, so this is the main screen of the HMI. Here you can see the robot operation as well as the camera operation right here next to it. So this right here will give you not only the status of the camera and the robot, but you can put the camera in setup mode and put the camera in run mode from here. Your run mode means that it can like actively do scans. It's essentially your auto mode for the camera, whereas like setup mode is the programming of the camera. Then up here at the top, we're taking account of the total scans that we're doing, how many okay scans there are, and how many not good scans there are. Obviously, this is not a normal production situation. We're scanning a bunch of bad hooks, so that way we can train the vision system to perform at its best. Down here, we have our data history. So data to the robot, data of the right hook, data of the left hook. I'll take you to the data of the robot. So this is the offset data of the robot, where the robot will essentially be doing its shifting if the hook is bent. So if the hook is bent, the robot will shift according to these data positions. So we're storing 16 registers or 16 positions of data, and you can see this data is coming in pretty tight. We're looking at this in millimeters. So this is 0.45 millimeters, 0.39 millimeters, 0.47 millimeters in the negative direction. And as you can see, we have -1 millimeters in Z, and it's pretty consistent all the way down, 0.20, 0.16, 0.14. And then we can go look at the, let's say, the right-hand hook data. So now we're looking at the right-hand hook individually. So this will help us detect if it's the left hook that's causing the problem or the right hook that's causing the problem. Because when you're looking at this data over here back in the robot screen, this data is the raw data that comes in from the camera, and then some math applied to it, some different equations to get us to this proper offset positions. These status screens are more of your operator user interface. So here's where you're going to get the status of an okay hook or a not okay hook. So we're looking at left hand independent, and then down here you also have right hand independent as well. So this will tell you if the XYZ data is close enough for the robot to offset and then place the part there. And it's also detecting special defect conditions such as a twisted hook or a bent hook. So there's separate tools that are in there to measure for these. These XYZ offset values will also fail, not in all conditions, but they will fail in some conditions where the XYZ value is just too large, and then the hook will fail. But these give you a actual indication of why they failed. And then we're also giving the data that you can look at to see by how much it failed. Now over here you have what is the master data. And so what the master data is, it's essentially the raw data coming from the camera. We then scan in a perfect hook. We then master that data as a perfect hook. And then that data gets stored here to then apply our math to. So right now the camera's actually giving us a 65 point, let's say 250 or something like that, right? And that's why we're getting a negative 0.235. I'm just giving you rough numbers, but essentially we've zeroed this data so it's much more easily readable, and you can observe it much more easily. So if this data was just coming in raw like this, you would see it bounce around at 65, 65.1, 65.2. And then you have to track that for all these data points. It's almost impossible to track that many data points without zeroing them. Whereas if you zero the data, I can come over here and I can look at this data and say, oh, okay, everything except for Z is coming in under 1 millimeter. And so if I see this data and then all of a sudden I see something come in at 5 millimeters, then you can very clearly indicate that there was an issue on that one. Especially if it's still okay, but you're just trying to overall just observe the data of the hook. This gives you that capability. Then down here in the bottom left corner, you have a left-hand hook tolerance. These are all your tolerances, right? X, Y, Z, as well as the twist and the bend. So this is the thresholds that essentially tells the system whether it's a good hook or a bad hook. Now, when it comes to the XYZ values, this will also prevent the robot from being able to do a offset. So if this value becomes too big and it fails, if this data fails, then the robot can no longer place to that position. And the reason for that is because the robot may crash in that particular condition. If it tries to offset too much, it could then put the robot into a crash condition, could crash the cameras, could crash into the rack. So that's why these thresholds are here. And it's just important to keep in mind, not only do they control a good and not good hook measurement, but it will also prevent the offset position of the robot as well. All right, so here is the offset data to the robot. So this is where we're taking in the combined data from the left-hand side and the right-hand side, and we are utilizing this for the robot's offset. So up here you'll see the master data save push button. So in order to master the vision system and to master the entire system, you need to select what is a perfect set of hooks, and then you need to scan that perfect set of hooks. I would suggest scan them multiple times, and then after you perform that scan, the tools inside the camera look good, click Save Master Data, and then it will then update these values to set that as the new reference for what a good hook looks like. So that way that you can take the most perfect version of a hook and call it, the 0 position. Or if ever you go to change the style of a hook to some degree, maybe you change like the length of it and it messes up like the Z value to the robot, then you can just remaster, scan, remaster, and then the system will be back up and running again. Now, there's a caveat to that, is if it's off too much where it messes up any of the vision tools, then you'll have to go in and modify the vision tools. And if the modification is significant enough, then you will have to go back in and reteach a new reference image in the vision system.